Hey everyone, welcome back to Learn with Rishi. I hope you're all doing well and ready to dive into another exciting math challenge. Today, we're going through an A-star IGCSE math paper together, and I'm going to break down each question step by step. So whether you're aiming for top grades or just sharpening your skills, this walkthrough will give you the tools you need to ace your next exam. So grab your pen and paper and let's get started. Fantastic. So this is in higher tier A-star paper, as it says, not for the faint-hearted. What I'd like you to do is have your calculators ready, unless that symbol does not appear, but also pause the video at any time, attempt the question, and then press play to get started and to see how I went through each section of the question. So with that being said, let's go ahead and let's dive into this right away. So rationalize 1 over root 7. So essentially here, what we need to do is multiply this by our denominator. And that would give us root 7 over 7, and you've got 2 marks in the bag. Wonderful. Part B, expand and simplify. So what does this mean? That means we're essentially going to have root 3 plus root 15, root 3 plus root 15. We're going to multiply it out. So 3 and 3 gives us 3 plus root 3 root 15 plus root 15 root 3 plus 15. Then we need to simplify this right away. We know that this can give us root 45 and root 45. But we know that this can be simplified to root 9 and root 5. Or should we say 3 root 5. We have 2 of these, so that's 6 root 5. And then we have 15 and 3. So altogether it will be 18 plus 6 root 5. And that is our answer. I hope that was clear. All I've done is expand the brackets out. As we know, 3 and root 15 will give us this, but 15 and root 3 will give us root 15 root 3. And then root 15 and root 15 is root 225, which gives us 15. We just simplify it and we're good to go. And it's also in the form of n plus m root 5. Marvelous. Okay, let's move over to II. ABC is a right-angled triangle. K is a positive integer. Find the value of k. So essentially, we're going to be using Pythagoras. So what does that mean? Well, that means we'll have k squared plus 3 plus root 5 squared, which will then equal to root 3 plus root 15 squared. Now, with that being said, we can use our answer to the previous question for this particular one. So we can have k squared plus 14 plus 6 root 5, and that will equal 18 plus 6 root 5. So it's essentially using the previous answer here for our section of what we expanded. So it saves us and gives us some time. I've also gone ahead and expanded this to give me 14 plus 6 root 5. And now essentially, if I take everything to the left-hand side, I know I'll have k squared plus 14 will equal 18, as we can eliminate the 6 root 5. We then need to make k the subject, so we know k squared will equal 18, take away 14, which is 4, so k will equal to 2, and we know it's positive, and there we are, k equals 2. I hope that was clear. Please remember, these sort of questions are what you would receive in the first few questions of the paper. But one thing to note is that this might seem tricky at first, but remember, every complex problem is just a bunch of smaller steps put together. So stay focused and let's break it down piece by piece. Question 2. Solve direct and inverse variation problems. So the force F between two magnets is inversely proportional to the square of the distance x between them. So when x equals 3 and f equals 4, find the expression for f in terms of x. Well, they've mentioned it's inversely proportional. So essentially we're going to have a fraction and we're going to have k over our x squared, as it's the square of the distance. And this will essentially give us k equals fx squared. So if x is 3 and f is 4, this gives us k equals 4 times by 3 squared, which is 36. So we can essentially say in this form that f will equal to 36 over x squared. And that is our answer. Beautiful. Okay, part B. Calculate f when x equals 2. Well, we know if x equals 2, then f was 36 over x squared, which is the same as 36 over 4, which gives us 9, and that is our answer. Okay, part C. Calculate x when f equals 64. So we follow the same route. We know f is 36 over x squared, but now let's substitute that value and let's make x the subject. So if we know fx squared equals 36 and x squared equals 36 over f, then what do? Well, we take the square over, so that becomes a square root 36 over f, but we then know that if f is 64, how does that work for us? Well, we can simplify this first and say x equals 6 over f, but by doing so, that's going to be x equals 6 over root 64, right? Now we've got that into play, we've swapped that over. We can then go ahead and simplify this as 6 over 8, or should we say 3 over 4 simplified, and there we are. So I've substituted the value, I've made x the subject, I've then gone ahead and simplified the root of that, and then I've substituted 64 in, and then simplified it. Marvelous. Okay, I hope the first two questions were clear. Remember, these are fast-paced questions. I'm not intending to spend over an hour on this. Okay, so question 3. Elliot did an experiment to find the value of grams meters per second squared. The acceleration due to gravity. He measured the time t seconds that a block took to slide L meters down a smooth slope of angle x degrees. He then used a formula to calculate the estimate for g. So we've got the values of this, and we need to calculate the lower bound and the upper bound for the value of g. So how do we do this? Well, we're going to take the max and the min of this, essentially. So let's start off by saying the g max and the g min. Okay, so we'll essentially go with 2 multiplied by the max amount that we have of this. So it will be L max over, and then we'll get the t value, which is our 1.3, and we'll get the min of that. As you know, we have to have the max and the min, and we'll have sine min x. And that would essentially equal 2 multiplied by a value 4.55. Remember, it's the upper bound of L, which was 4.5, over 1.25, which again is the lower bound of t, and that's sine 29.5. Now we've got that, we can simply equal that to 11.8272, or if you have it to 3 decimal places as they've requested, that's just 11.827. We're going to do the same for our minimum now. Okay, so 2 times L min over t, and this time we're going to get our max squared, and then we get our sine max for x. This will be the same as saying 2 times 4.45. Remember that, we're getting the minimum of the lower bound. 1.35, and that's the upper bound, right? We square that with this side value, but this time the upper bound is 30.5, and that again would be seen as 9.6217, or should we say 9.622 for our 3 decimal place. So essentially we have 9.622, or for the upper bound 11.827, and there we are. That's our question calculated. So part B. Use your answers to part A to write down the value of g to a suitable degree of accuracy, and explain our reasoning. Well, we know, apologies, I said grams there. For gravity, it's 10 meters per second squared, right, as the approximation. And as this is the highest level of accuracy to which the both bounds agree, that's our value of gravity to a suitable degree of accuracy. Okay? Marvelous work. So once again, and when you solve these steps successfully, you can now understand how to tackle this. So always trust the process and the solution will unfold. Don't worry if you get stuck at some point. That's part of the learning process. Okay, question 4 here, team. We've got simultaneous equations. One is linear and the other is non-linear. So what are we going to do first? Well, we can go ahead and take equation 2 and make y the subject. So y equals x plus 3. Okay, let's go ahead and substitute that y equals x plus 3 into equation 1. So we have x squared plus x plus 3 squared equals 29. I'll then go ahead and expand this directly. So I'm left with x squared plus 6x plus 9 equals 20. Now I've gone ahead and do that. I'm going to simplify this. So by simplifying this right away, I'm going to be left with 2x squared plus 6x minus 20 equals 0. Remember, this is in the form of ax squared plus bx plus c. But again, we've got even numbers, so we can half this, and we'll be left with x squared plus 3x minus 10 equals 0. We can then go ahead and factorize this right away. So by factorizing this, we need two numbers that multiply to get to 10 and add to get to 3. So it's x minus 2 and x plus 5, and that equals to 0 as well. So by solving this, we need to know that x can equal to positive 2 or x can equal to negative 5. And then we go ahead and we sub these values into the equation 2. So that was y equals x plus 3. So by substituting that right away, what can we say? We have y equals to 2 plus 3, which equals 5. So we know one of the values of y is 5. Or we can say y equals to minus 5 plus 3, which is minus 2. So that tells us that our x can equal to 2 and our y can equal to 5, or our x can equal to minus 5 and y can equal to minus 2. So these are our 4 values. And we can check this as well by incorporating it into equation 1 if we need to. So 2 squared plus 5 squared equals 29, as that is 4 plus 25. Beautiful. I hope that was all clear, and hope you are clear with the steps that you need to take as per these questions. Okay, team, let's go for question 5. I will perhaps keep this quite limited to the questions that I am covering, and we'll do this in different increments. So question 5, rearrange more complicated formulas where the subject may appear twice or as a power. So if we are rearranging the formula to make A the subject, the first thing we will do is cross multiply. Okay, so if we go ahead and multiply this out, we can just have p n plus a, which equals to n squared plus a. So you can see I've made it all into one level. I can then go ahead and expand this out as well. So I've just expanded out the brackets. And then step 3 can be to put this all on one side. So we could have pa minus a equals n squared minus pn. Right, so we've put that all onto one side. And then we can remove the factor of a as well if we need to. So we can just have p minus 1, which again equals to n squared minus pn. Once I've gone ahead and done that, we can then make a the subject. So we now know, as it's requesting, a will equal to n squared minus pn over p minus 1. And that there is our answer. Okay. Now, there is another way to also do this as well if you want to take the n over to the left-hand side and the a onto the right-hand side. You would still need to factorize the a out, and then you could make a the subject, but this is initially what you would get. So we have n squared minus pn over p minus 1. Marvelous. I will stop there for the first part of our series here. But remember, look how quickly we can move through this one once we know what to do. Efficiency is key, so practice makes perfect. Keep working on these and your speed will improve over time. But that's it for today's walkthrough of the A-Star Maths paper. I hope you found it helpful and that it's given you some valuable strategies to use in your own exams. If you enjoyed this video, don't forget to hit that like button, and if you want to keep improving with me, subscribe to Learn with Rishi. I definitely think this is worth subscribing for, and don't forget to turn on that notification bell to never miss an update. Keep up the great work, stay confident, and keep pushing for that A-star.